Okay, everybody, this is 7.10 we do. In this problem, we know the Kc value is 128. What we are trying to do is we're trying to figure out which way the reaction is going to have to go to reach equilibrium. We're starting with a little bit of reactant and a little bit of product. We need to figure out whether we're shifting to the left or shifting to the right in order to get to equilibrium. So the first thing we're going to do is we're going to calculate Q. We have to know which way the reaction is going to go, either left or right. So we are going to plug these numbers in for Q that they give us. Q is going to be equal to, let's see, these are molarities. So the concentration of B squared, concentration of C, all over the concentration of A. So there is our equilibrium expression. Plugging these numbers in, we get 3.20. There's a decimal there. There we go. Squared times 1.85 all over 2.50. That gives us a value of 7.58. And calculate that out. So when we compare that to the Kc value, that tells us our Q is a lot smaller than our Kc. So our QC is a lot smaller than our Kc. So we're going to have to produce products. More product. Or shift right. Because we need this equilibrium number, or we need our equilibrium constant to be higher, basically. So at our reaction quotient tells us we're at 7.58. We definitely need this to go up in order to say that we're at equilibrium, which is 128. So these numbers on the top have to be bigger. All right, so we're going to need to produce more products, so we're going to shift to the right. The reason we have to figure that out is we need to know whether these changes are positive or negative. So we know, since we're shifting to the right, that we're going to lose reactant and we're going to gain product. So I'm going to go ahead and fill that in. What that means is when we plug these numbers in, I like actually in this one how they did equilibrium with x, 2.50 minus x, 3.20 plus 2x. Oh, that shouldn't be a 2x. Get rid of that. That should just be plus x. And then 1.85 plus x. So now what we have to do is we have to figure out what x is. And I am going to tell you right now that for this one, it is not going to come out to be easy. I'm going to scroll this up a little bit. Let's see, can I get it to move? There we go. Not bigger. There we go. So when we plug this into our Kc, we know that Kc is equal to 128. 128 is going to be equal to 3.20 plus 2x squared times, let's see, 1.85 plus x all over 2.5, that's a 2, 2.50, let's see, minus x. Now, you could use the quadratic equation for this, or if you have a solve button on your calculator, you can solve this out. You could graph it, whatever. I'm just going to tell you the x value here is 1.50. And this might be a fun one to get out a graphing calculator and see if you can figure out what x is. But x ends up being 1.50. So when we go back and we plug that value in back in here, we end up with 1.00 molar for the equilibrium concentration of A, 6.20 molar for the concentration at equilibrium of B, and 3.35 molar for the concentration at equilibrium for C. Again, this is not an easy one to solve, so you do have to use the quadratic or the solve function on your calculator. Do not expect to see something like this on the AP exam. but it's not a bad idea to take a look at one and see if you can solve it.